Hi guys, my name is Priest. I will be your physics 2 tutor guy today. We'll be working on physics and then we'll be simplifying the concept and working together. So and a lot of stuff we'll be discussing it on the group that we've created as the team of the tutor. So let's begin. Alright. A junction right now is a point where two or more wires meet. The function of a junction is to divide the current that comes in. Let's say for an example, I've got I1 coming from the top going into this junction. What will happen is that I1 will separate into I2 and let's say the other current will go down there. So what does the junction rule say? Junction rule say the sum of the current that enters the junction must be equal to the current that leaves the junction. Let's say this is my I1 and this one, let me label it my I2 and that one to be my I3. So because these two are leaving the junction, they will be equal to the one that is entering the junction, which means in other words, it's going to be I1, which is equals to I2 plus I3. So the ones that are leaving the junction must be added to give the sum of one that is entering. Let's say I decide to give an opposite of what is going on there. Let's say I decide to draw another junction here. And let me give you different direction once again. So let's say this one, the current is entering the junction. That's I1. This one is entering the junction again. And then this one is leaving the junction. So now I have two currents entering the junction. Let's label this maybe I1, which is the one entering. This one I2 is entering again, while I3 is leaving the junction. I say junction rule says the sum of the current that are entering the junction must be equal to the one that are leaving the junction. So which means this plus this, because they are entering, they're doing the same thing, they're entering into the junction. Then which means I1 plus I2 equals to I3. So this is how you improvise the junction rule. Let me give you the last example. Let's say on the last example now, on the junction rule, these currents are all entering, or we can say they are all leaving the junction, but this one, all of them are entering the junction. Sorry, give you that direction. It's entering the junction. So now, since there is nothing leaving the junction, let's label this one as my I1, and label this one as my I2, and label that as my I3. So since all of them are doing the same thing and nothing is leaving the junction, when nothing is leaving the junction, it simply means zero is leaving the junction. So all of them are entering the junction, which means my I1 plus my I2 plus my I3 will be equals to 0. Why equals to 0? Because there is nothing leaving the junction. So this is how you interpret the junction rule. Make sure you don't make a mistake on this one. There's something about a resistor that you need to know. The polarities of a resistor are determined by the direction of the current. By polarity, I mean the positive side and the negative side of the resistor. So which means when the current decides to go in this direction, the polarity of the resistor will be where the current enters, there's going to be a positive side of the resistor, and where the current leaves is going to be the negative side of the resistor. So let's say current decides to change direction. When current enters in this different direction, the polarity of the resistor will change. I said where the current enters will be the positive side of the resistor, and where the current leaves will be the negative side of the resistor. Very important for you to understand this concept.
That's good.
Okay, perfect. Right, the first thing that you need to understand here, it is to get our junction rule formula. So as we see that this is the junction, right? We have already explained about how we are going to get the junction. So this one is entering the junction, this one is leaving the junction, and this one is entering the junction. So which one is going to be added with which one? Do you see? These two are entering the junction. That's what the junction rule says. Sum of those entering the junction must be equal to those leaving the junction. So which means my formula for junction rule is going to be I1, which is this one, plus, because it's entering the junction, with I2, and what is leaving the junction is equals to I3. Then this will be taught as my equation 1. Now, first thing first, I've already explained to you. Here the direction of the current is already given to you. Remember, the direction of the current, if it is coming down here, it's a sign that it was going all the way up there, and then it's joined to this part. In other words, which means it entered through this resistor in this side, which means this side of the resistor is going to be positive, and that side of the resistor is going to be the negative side. But the polarities of the battery won't change. It's only the polarity of the resistor that are affected by current. So the polarity of the battery will remain positive and negative. Is there any other resistor there? No. Then I come in this side. Second part, where is the current going in the middle part? It's going in this direction, which means, in other words, it's coming from this side, coming here, which means it entered through this side and it left through that side. So the positive side of the resistor will be where the current enters, and the negative side will be where the current leaves. And let's go to the third one. The third one, it shows me an arrow going down there. It's a definite sign that that current is going to what? To move in this direction, and then it's going to enter there again. Do you see that? So now, which means when it comes in this direction, the positive side of the resistor will be this, because it's entering through here. Where is it leaving? On this side, which is going to be the negative part of the resistor. Now, once you get this done, the most important thing it is to choose what we call direction. So when you choose direction, your loop, you have to make sure that if you choose the loop to be clockwise, all of these loops must also be clockwise. So both of them must be clockwise. Don't choose a clockwise here and choose an anti-clockwise here. Let's call this loop 1 and let's call that loop 2. So if you choose an anti-clockwise, you still get the same answer. If you choose the clockwise, you still get the same answer. The only difference will be just the calculations and stuff. But at the end, you still get the same answer. So the direction of the current is already given. So now, there is one thing I want to teach you. There is what we call the V rise, and there is what we call the V drop. Okay, when is voltage rising? When a number is rising is when a number comes from a negative point going to the positive point. It's like you're counting from negative 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 1, 0, 1, 2, 3, you are increasing. Do you see that? 4, 5, you are going from a negative number going to a positive number, you are rising. But when you are coming from a positive number going to a negative number, we say you are dropping. So now, I'm going to check, because the voltage rule says the voltage rise must be equal to the voltage drop. So I'm going to write V rise equals to V drop. And then now I'm going to come back to my circuit. So on the circuit now, I have to determine my V rise. I've already explained what a V rise is, and I've already explained what a V drop is. Now, my loop will help me to determine whether the voltage is rising or the voltage is dropping. So I say to you, when a number is coming from a positive going to a negative, it is dropping. But when it's coming from a negative going to a positive, it is rising, right? So let's look at our loop. Our loop is going in a clockwise direction, which means we must check for the first resistor. Here is it. It's positive and it comes negative, which means it starts on a positive and it ends on the negative. Then we call that a drop. We write drop there, because it starts on a positive, goes on a negative. We come to our battery now. Battery, it's a positive going again to a negative. What's that again? That's a drop. And then we come here again on this resistor. We're checking loop 1, right? So here is starting on a negative, going to a positive. What is that? That is a rise, because a number is starting from a negative, rising up to the positive number. And then we come to a battery now. Our last battery, it starts on the positive and it goes on what? On a negative. What is that? That's a drop. So everything that is written drop, you will write it under voltage drop. So you'll just say equals to. Because this is voltage. V drop means voltage drop. Remember, Ohm's law says, if I want to get a voltage, my voltage will be equals to IR. So which means I times R will be equals to the voltage, isn't it? So now I come to my circuit now. So if I want the voltage on this resistor, it will be I times R. What is I in this resistor? My I is I2. So now I come here, I will say I2 multiplied by 4. Do you see that? So I will write it under drop, and then I'll come here. On the drop, we have a 14 now, but a 14 is in voltage already. There's no need for me to write 14I what. So I'll write it directly as 14 because it's already given in voltage. So I will come on the third one right now. On the third one, I've got resistance and I've got current here. And the current that is moving here, it was given to us that is what? It's I1. Then I'm going to come here now. I'm going to say plus 6I1. No, it's on the rise. Sorry about that. So we are going to come here. On the rise, we are going to... So this one is a voltage rise. So if it is a voltage rise, it's going to be I1 6, right? And then we are coming here again. See, this one is a drop, right? Because it's coming from positive and negative. Then we are going to write it under drop 10 volts. So we've got everything that we need here. But now we just have to make the current the sub with the formula, which means we are going to divide here by 6. Divide here by 6. We can make any of them. You can make either I2 or I1 sub with the formula, depending on your own choice. And then we're going to divide that by 6 and also divide that by 6, or even add these two to become a 28. Let's just add them. So it will be a 28. Is it 10 plus 4, which is 24, right? Divided by 6. And then it will simply cancel off. Then my I1 equals to 2 over 3 I2 plus 4. And then I'll call that my equation 2. Ready? Okay. Now we are going to do the loop 2, which is our second loop. Remember, I told you about the V rise and the V drop. So our loop is going to determine which one is rising and which one is drop. Now we come to this loop now, the second loop. So the current is the loop is going to start hitting the negative, going to the positive. What is that? That's a rise. See that? And then when it comes on the second one, it's going to hit a positive and then hit a negative, and then that's what? That is a drop. And then it's going to come again here. It will hit a positive and hit a negative. Then that's a what? That's a drop, because it's coming from positive going to negative. So now we are going to write your formula now. Your formula says V rise equals to what? Equals to V drop. So everything that is under drop, you're going to write it here. And everything that is under rise, you're going to write it here. How many rises do we have? We only have 10. So we're going to put 10 is equals to. How many drops do we have? We've got 6 I1 plus. We come here, then it's going to be 2 I3. Remember, the equation that we got on the first, when we did the first loop, is this one. But now, in the first equation, the first equation is the one that is going to guide us on which one to get rid of. On equation 1, we've got only I1 and I2. We don't have I3, which means we need to get rid of this I3, right? How are we going to get rid of this I3? And then that's where the game changer come into place. I1 plus I2 equals to I3. So wherever there is I3, I'm going to substitute I1 plus I2, because I3 is equal to that. So it's going to be 10 equals to 6 I1 plus 2. Where there is I3, I'm going to say I1 plus I2. So now that I have this, right, I'm going to multiply by 2 throughout. FOIL method to simplify my circuit. So 6 I1 plus 2 I1 plus 2 I2. Right? Do I have something if similar? Yes. These two are what are like terms. So I can add them. So it's going to be 10 plus 6 plus 2, which is 10 equals to 6 plus 2 is going to be what? 8 I1. Right? And then I'm going to say plus what? 2, which is this one. I2. So now, do I have I1? Yes, I've already made I1 substitute the formula. So wherever there is I1 there, I'm going to substitute by this. Once I substitute this, you will find out that everything now will have I2 here. So now I'm going to come down here. I'm going to say 10 equals to 8. Where there is I1, I'm going to substitute all of that. Then it's going to be 2 over 3 I2 plus 4 equals to plus 2 I2. Now, do you see? I2 and I2 is the only one left here, which means we can now freely go and calculate I2. But before we go there, we have to use FOIL method to simplify our equation and then calculate our I2. So here, we're going to have a 10 equals to 8 times this, which is 16 over 3 I2 plus 8 times 4 is going to give us a 32. So now that we have done this, we are going to say I2. Remember, 16 over 3 plus I2, right? These two are what? Common factors. They are the same, right? We can add them, right? Because they are common. So we have to add 16I3 plus 2, right? 16 over 3, which is 16 over 3 plus 2. And then this is going to give us, when we write it here on top, it's going to give us it's going to give us 22 over 3 I2, right? Which is this one, 23 over 2 I2. Now I'm going to take this to the other side. Then it's going to be 32 minus 10. Then it's going to be minus 22, because the 32 will be negative on the other side. So it's going to be minus 22. So now that we have this, we can divide all of this to get our I2, right? So now my I2 will be equals to negative 22 divided by all of that, which is what? 22 over 3. If we divide that, which is negative 22 divided by the answer there, 3. And then this is the answer that we're going to get. Now that we already have our I2 as negative 3, because if we divide this, we're going to get negative 3 as our answer. So now what we're going to do here, we are going to get our I1. How do we get our I1? If we have I2, we can simply get I1, because that's all we need to substitute here. So which means now my I1 will be equals to 2 over 3 multiplied by, wherever there is I2, I'm going to substitute with the value that I got, which is going to be what? Minus what? Minus 3 plus 4. See that? And then automatically this will cancel with that one, right? And then now where I'm going to have what? I'm going to have a minus 2 because of this minus. So now my I1 equals to minus 2 plus 4, which now my I1 will be equals to 2 ampere. Now I'm going to go back to the formula, the equation 1 that I got in the beginning. Now I have I1, I have I2, I'm looking for I3. So I'm going to consult this equation to get my I3. What is my I1? And what is my I2? Do I have my I1? Yes, I do. My I1 is what? Is a 2. So wherever there is I1, I'm going to put a 2. And then wherever there is an I2 now, I'm going to put the minus 3 that I got, which is equals to minus 3, right? Equals to I3. Then now, minus 2, or 2 minus 3, then it's going to give me a minus 1. And that's how they got the answer on the guide as an I3. So this is how it's done.
Yeah.
Now, there's one thing you need to understand about the battery. Let's look at this circuit where direction is not given at all. So here they didn't give us the direction of the current. So now, what you need to know about the movement of current is that current moves from the positive terminal of the battery to the negative terminal of the battery. That's the direction of current. Let's say maybe it was like this. Okay, so it has to move from the positive going back into the negative terminal of the battery. Very important for you to understand that. And we make it a little bit bigger so you can see it. So that's the direction of current. So now let's come here and analyze our circuit. So current is moving from the positive terminal going into the negative. It has to go into the negative terminal of the battery, which means it's going to leave from this direction going up. Is current going to, when it reaches the junction, is it going to go in that side? No. The reason why, there is a positive terminal of the battery. It can't go there, right? And then here, there is also current leaving. Do you see that? And then it's going to come up also in this direction, right? So this current that is coming here, it won't go in this direction because there's also a positive terminal. It sees that as an exit point. So, which means current is going to come in here and come in here, and then this is the only alternative for the current to go, which is in this direction. So why this direction? Because it's going to come back and reach the negative terminal of the battery and also reach another negative terminal of the battery. Now, automatically here, we already have our first rule, which we call the junction rule. Do you see that current is entering the junction, and also here it is entering the junction, and here it's leaving the junction. Now, because here you are giving yourself direction, you can choose this one maybe as your I1, and choose the middle one as your I2, and choose the third one as your I3. Because you are the one choosing your own direction, you can choose which one to be the I1 and which one to be the I2 and which one to be the I3. Now, junction rule, I've already told you. Some of the current that are entering the junction is equal to the one that are leaving the junction. So this one is leaving the junction. This one is entering the junction. This one is also entering the junction, which means I1 plus I2 must be equal to I3. The sum of those are entering the junction must be equal to the ones that are leaving the junction. So now my I3 will be equals to I1 plus I2. Okay, now we have explained the junction rule. Let's look at one of the examples that are given to us. Remember, the junction rule says the sum of the current that are entering the junction must be equal to the one that are leaving the junction. So we are going to look at the one that is entering. It's a 5. And the one that is leaving is a what? It's a 2. Which means the ones that are leaving must add up to 5. Which means there must be one that is leaving here. Which is a what? Which is a 3 ampere. Why am I saying it's a 3? Because a 2 has already went up there and then a 3. So if I add these 2, they must give me back this 5. So I already have a 3 because the aim it is to get what my I is equals to. We don't know what the I is equals to. So we are going to come back again to the far end. We cannot come to the second because we don't know the one entering, the one leaving. So this one is going to assist us in getting that. So we have the one that is leaving. Already the arrow has been given to us, which is a 4. And we have the one that is entering. You see that? Which is a 2. But the one that is leaving is a 4, which means there must be another one that is entering again. Because I told you, those 2 that are entering must add up to the one that is leaving. So, which one must be equal to 4? It must be what? Must be 2. Which if I add a 2 on top of this 2, it must give me the sum of the one that is leaving. Sum of the currents that are entering, which is 2 plus 2, equals to the one that is leaving, which is equals to 4. So now, this 2 is the current that is leaving here. Do you see that, ne? You see? And then now I'm going to come on this one. I have the one entering, I have the one leaving. So which means I have to find another one leaving. Sum of the current that are entering must be equal to the one that are leaving. So I see that the bigger one is the one that is entering. It's splitted into 2 here, which means it must also be a 2 again here. Because a 2 plus 2 must be equal to 4. Sum of the one entering must be equal to the one leaving. So automatically now, I have 2 of them entering, right? They are entering. Sum of the current entering must be equal to the one leaving, which means the leaving one must go away, down there. So which means this plus this must be equal to what? Must be equal to 5 ampere. The one that is leaving. Sum of the one entering must be equal to the one leaving. So my I equals to 5 ampere.